Okay, this is 5.9 conic applications. So we have a room in the shape of a semi-elliptical arch. We've got 100 feet in length, 60 feet wide. It's to be designed as an auditorium. How high is the ceiling? 25 feet from the center. So it doesn't matter if you have a vertical or a horizontal. I'm going to draw me an ellipse here. We know we have 100 feet here, 60 feet here, and again, it's not going to matter if you flip-flop those. I'm going to make this my center of my ellipse. And then I'm going to start setting up my equations. So if 0 is my center, then I'm going to have x squared and y squared, and of course it's equal to 1. And then you have an a squared and a b squared. So remember, a is from your center over. So if you have a squared, that's going to be 50 squared. And then your b would be 60. That's already set. Okay, so it says we want to know where it's 25 feet from the center. So if you go 25 feet from the center and you go up, and this is just a guess, 25 feet out, and I want to know what it is at this point. So this would be an x of 25, and you don't know what this value is. So I'm going to go ahead and plug these in. So 25 squared over 50 squared, and I don't know what y is, over 60 squared equals 1. So 25 squared over 50 squared is going to reduce to 1/4, plus y squared over 3600 is equal to 1. And then I'm going to move everything over to one side. So y squared over 3600 is equal to, common denominator, 4/4 minus 1/4. So y squared over 3600 equals 3/4. And then I'm just going to cross multiply. So 4y squared is equal to 10,800. Divide by 4, and you get 2,700. Take the square root, and you get a y value of about 51.962, which is a really tall roof at 25 feet out. So if you can set it up, it's just algebra work. So the cables of a suspension bridge are in a shape of a parabola. The towers supporting the cables are 600 feet apart, 800 feet high. If the cables touch the road surface midway between the towers, what is the height of the cable from the road at 150 feet from the center? Okay, again, it doesn't matter if your parabola is horizontal or vertical. Here's my parabola, 600 feet apart, and let's do 80 feet high. So again, I'm going to make my center right here in the middle to make it really easy. So again, it doesn't matter if you do x equals or y equals, you're just looking for a missing variable. So I'm going to make it easy and set it up as a y equals, no matter what my picture looks like. So y equals a, parenthesis, x minus your h quantity squared, plus k. Since my center is 0, that would make this an a times x minus 0 or plus 0, and then plus 0. So basically we know this point right here, which is an ordered pair. Your a value right here is 300. So your x and your y, your x is 300 and your y is 80. So I'm going to plug that in first. So that gives me 80 is equal to an unknown a. And this gives me a 300 minus 0 or plus 0 quantity squared with nothing out here. So 80 is equal to a times 90,000. If I divide by 90,000, all I can do is cross out a 0. So this is 8 over 9,000 is equal to an a value. So let's see, let's write down our equation. So y equals 8 over 9,000 x squared. So this is my equation basically. Now what is the height of the cable from the road 150 feet out? So now I can do my next thing. So if I go 150 feet out, so that's my x value. That's all I need to do. Plug that in. Plug in 150 for your x and square that. You're definitely going to need a calculator for that. Just plug this straight into the calculator and you get 20 feet.